finding the equation of a straight line graph. We have already shown you how to sketch different graphs. Let us look at different graphs and their standard forms. Look at the table. The first graph is the graph of a straight line graph. It has the equation y is equal to ax plus q. Look at the second graph. This is a graph of a parabola. It is also called a quadratic graph. It has the standard form, which is given by y is equal to ax squared plus q. Look at the third graph. The third graph is the graph of a hyperbole. It has an equation y is equal to a over x plus q. Finally, we have an exponential graph as our last graph. The exponential graph has the equation y is equal to a multiplied by b to the exponent x plus q as its standard form. Let us start with finding the equation of a straight line graph. Before we do that, let me explain gradient or slope. Have a look at this example. In this example, we want to sketch the graph of y is equal to 2x plus 4. Let us quickly write down the equation of our graph. Our equation is y is equal to 2x plus 4. Underneath our given straight line graph, let us write the standard form equation. The standard form equation is y is equal to ax plus q. So far we have y is equal to 2x plus 4 and y is equal to ax plus q. The q is the y-intercept. It is the point where the graph will cut the y-axis. Q is equal to 4, which means the graph will cut the y-axis at this point. Look at the coefficient of x, which is 2. This means a is equal to 2. A is the gradient. If the gradient is positive, our straight line graph will be like this.
I have a question, Phoenix. If the gradient was negative, show me how the line will look.
If the gradient is negative, your line will slope downwards like this. Let's quickly summarize. Look at the picture. If the gradient is positive, the line will slope upwards. If the gradient is negative, the line will slope downwards. In this case, we know that our gradient is positive. Remember, gradient is the value next to the x. Gradient is this 2. Because the gradient is positive, our line will be an uphill like this. Remember that on an uphill line, the car will struggle to go up. Let us now draw a vertical line that touches our line. So far we have this picture. We already know that our y-intercept is 4. So we put 4 here. Look at the graph. 4 is here. Let us quickly locate the origin. It should be somewhere here. The origin should be below the 4. Look at the picture. Let us now draw a horizontal line that passes through the origin. Look at the sketch. Look at the graph. Origin is here. This horizontal line, that we just drew is called the x-axis. Look at the graph again. Now that we have drawn our line, our problem now is to find the x-intercept, which is here. This will not be easy. Let us quickly remind you that gradient is change in y over change in x. What it means is that two numbers were divided to get 2, and 2 is our gradient. Look at the graph. The distance from this point, which is 4, to the origin, which is 0, is 4 units. This is true because 4 subtract 0 is equal to 4. We can therefore say change in y is 4. We write it like this. This triangle means change. This triangle is also called delta. So delta y is equal to 4. Look at the graph again. Let us call the distance from the origin to the x-intercept delta x. We write it like this. We already know the gradient, which is m, it's equal to 2. We also know that delta y is equal to 4. Delta x is an unknown. We know that delta y over delta x gives us the gradient. This means delta y over delta x is equal to 2. This 2 is our gradient. In a place of delta y, let us put a 4 because delta y is equal to 4. So far we have 4 over delta x is equal to 2. Ask yourself, which number must be divided into 4 to give us 2? That number is 2. So delta x is equal to 2. This is true because 4 over 2 is equal to 2. Look at the graph quickly. Delta x is equal to 2. That's the distance from the origin to the x-intercept. This means the x-intercept must be -2. Remember, the graph touches the left side of our horizontal line. Values to the left of 0 are negative, and the values to the right are positive. Look at the graph. Y is equal to 4 is our y-intercept. Y is equal to 4 is here. X is equal to -2 is our x-intercept. X is equal to -2 is here. So our graph is complete. Look at the picture. Let us have a look at this example. In this example, we are given a graph. A graph is drawn for us, and we want to determine the equation of the given graph. Look at the graph. The distance from here to this 3 is 3 units. This is true because 3 subtract 0 is equal to 3. So this means delta y is equal to 3. Look at the graph. The distance from here to this 2 is 2 units. This is true because 2 subtract 0 is equal to 2. So this means delta x is equal to 2. Remember that the distance is always positive. To calculate the gradient, we simply divide delta y by delta x. So far we have m, which is the gradient, being equal to delta y over delta x. Look at the line. This line is a downhill, which means our gradient is negative. Let us now continue m, which is the gradient, it's equal to delta y over delta x. This m represents the gradient. In the place of delta y, we put 3. In the place of delta x, we put 2. So far we have m being equal to negative 3 over 2. Remember, our line is a downhill, so our gradient has to be negative. Let us now put negative 3 over 2 in the place of a in the equation. Y is equal to ax plus q. So far we have y is equal to negative 3 over 2x plus q. Please note that this letter a represents the gradient whenever we have a straight line graph. In other graphs, a is not the gradient. Let us now find the value of q, which is our y-intercept. Look at the graph. Look at this 3. This 3 is the y-intercept. It represents the letter q. In the place of q, let us put 3. So our equation of our graph is y is equal to negative 3 over 2x plus 3. Now that you have worked with finding the equation of a straight line graph, let us see if you can try this activity.
The first one has been done for you.